Hello and welcome to this video lecture presentation on the multiplication and division of polynomial fractions. This section heavily relies on your factoring abilities of trinomials, which was discussed in prior lectures. So please, if you're not that good at factoring trinomials or doing difference of two squares and so on, please take a look at the prior videos that I created. So basically, here's what we want to do. If we start off with a normal fraction, we could break down 8, for instance, into 4 times 2. I could break down 14 into 7 times 2. I could keep 6 as 6 times 1. And 24 I could break into 6 times 4. So when you're multiplying by fractions, not only are you able to cancel similar values vertically, but you're also able to cancel them diagonally if there's any that exist. So here's some examples. I have a 2 here and a 2 vertical from it. I have a 6 here and a 6 vertical from it. Now I have a 4 that I could cross cancel with this 4. There's nothing else that we could cancel, so we're left with 1 over 7. That's basically what we're going to be doing, except that we have to factor these first, because remember we said if terms are separated by plus and minus signs that we cannot just cancel them. For instance, I cannot just cancel these x squareds because they have to be multiplied by something, not have a minus sign or a plus sign in between them and another term. So x squared plus 2x minus 3 we could break down into two binomials. The x squared breaks down into x and x. The third term is minus. Only one way to get a net minus answer when multiplying our last two terms here. That's a minus times a plus, which will give me a minus. So now we say what two numbers are multiplied together will give me 3. When added or subtracted will give me 2. That is 3 and 1. So now the question is, where does the 3 go? Where does the 1 go? Remember we said we have to look at the sign of the middle term. Since it's positive, the larger of the two factors have to match the sign of the middle term. So the 3 goes with the plus, the 1 goes with the minus. Now we have x squared minus 4. This is a difference of two squares because I have two terms, a minus sign between those two terms, even exponents, and I could take the square root of the 4 evenly. So that breaks down into x minus 2 and x plus 2. Now for the second fraction here, we'll look at the numerator. The x squared breaks down into x and x. Once again, a minus sign on that third term will give me a minus and a plus. We ask the riddle, we say what two numbers are multiplied together will give me 6, but when added or subtracted will give me, we can assume there's a 1 in front. So the answer would be 3 and 2. So now the question is, where does the 3 go? Where does the 2 go? The larger of the two factors between 3 and 2, in this case it's 3, has to match the sign of the middle term. So the 3 goes with the minus, 2 goes with the plus. And then we're going to factor out this trinomial here to x and x. The third sign of the third term is plus. Two ways to get a net positive answer when multiplying your last terms here. A plus times a plus or a minus times a minus. We can't put in a plus times a plus because there'd be no way to get a minus middle term. So it has to be minus a minus. So now we say what two numbers will multiply together will give me 4. When added or subtracted will give me 5. That'd be 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. So now we look into canceling similar terms. I have an x plus 2 and an x plus 2. And I have an x minus 1 and an x minus 1. It looks like there is nothing else that is common that could be canceled vertically or diagonally. So therefore, I'm going to be left with, I'll show that down here, the answer, quantity x plus 3 times the quantity x minus 2 times x minus 3 over x minus 4. And that would be our final answer there. Now let's look here. Division of polynomial fractions are very similar to the multiplication of polynomial fractions. The only difference is there's a couple extra steps. We have to change the division sign to multiplication. So let me first factor this first fraction. 5a minus 1, a and a, minus 2 plus 1. We already discussed similar problems like this, so please go back and check if you're not sure on the factoring here. Here, we're going to switch this to the division sign of multiplication, then you take the flip of the second fraction, so now the denominator is now the numerator. So now here, there's no way to get this 10 off of our leading term. So I'll show it right here, 10a squared plus 13a minus 3. It's a factor by grouping factoring problem that we've discussed. First step, multiply the first and the third term together. 10 times 3 is 30. So now the next step is you ask the riddle, what two numbers when multiplied together will give me 30, but when added or subtracted will give me 13. What do we have? 30 and 1, 15 and 2, 6 and 5, 3 and 10, and the candidate would be 15 and 2. So now, because 15 times 2 is 30, but 15 minus 2 is 13. So now the next step, we need to expand out this problem, specifically the middle part of this, so that the factors are reflective of being part of that middle term. So it's 10a squared plus 15a minus 2a minus 3. There's my factors, 15 and 2. I put them in just like this. This and this are exactly the same thing. This is the middle term is just expanded out. 15a minus 2a is 13a. That's how I know to set up the plus and minuses as such so that I could get back to the middle term here when I throw in my factors into the polynomial expression. So now the next step is factor by grouping. So what's common between 10a squared and 15a? Looks like it's a 5a. I'm left with 2a plus 3. 5a and 2a is 10a squared. 5a times 3 is 15a. Looks like I could factor out a minus 1. I'm left with 2a plus 3. Now I compare this with this. I look to see what's the same. That's a 2a plus 3. So I could cross that off my list. And then what am I left with? 5a minus 1. That's supposed to be a minus. Ignore that little dot there. So that's how we factor this. So now I will replace this 10a squared plus 13a minus 3. So let's recap. We change the division sign to multiplication, then we flip the second fraction. So this part here is the top. The a minus 2 is now the bottom. And here is my 10a squared plus 13a minus 3 all factored out. So I get 2a plus 3 times 5a minus 1. So here we could see we have a minus 2, that cross cancel, of 5a plus 1, or 5a minus 1, I'm sorry, that cross cancels, and it looks like there's nothing else we could cancel, so our answer is going to be made up of whatever we didn't cancel. Quantity a plus 1 times the quantity 2a plus 3. And that's how you solve it. So here's an example for you. Please, if you like, pause the video, try to work this out and get an answer. And once you get an answer, hit the play button and see if what you did matches what we get. Okay, let's see how we did. So 6, I'm going to break down into 3 times 2. 3x plus 4, there's nothing common between the two, so I can't cancel them. I'm going to change the division sign to multiplication. Now this denominator is now the numerator. So now what is common? 3 and an x. So what am I left with? 3x plus 4. Now what do I have up here? Our top now is now the bottom. What's common between 2x and 2? That's a 2. I'm left with x plus 1. So now we have everything all factored out. We have terms that are multiplied to one another that we could potentially cancel, because even though this is 3x plus 4, we can lump this in parentheses and assume that it's multiplied by 1. So here I have a 3x plus 4 and a 3x plus 4. Here I have a 2 that I could cross cancel. So now I'm left with 3 times 3x, which is 9x, over x plus 1. And this concludes problems related to multiplying and dividing by polynomial fractions. Thank you for watching and listening. Have a good one. I wish you luck with this stuff. Bye-bye.